and we talked about this. I think I used this exact example last week. Do you know how far it is to Glenwood Springs? If you start at
43
Fishing?
miles.
Oh, it's like,
40, yeah,
yeah, it's like 40 something.
It's like
We can't use 40 something in math class.
43.
All right, we'll take a stab at it.
45.
Okay,
Let's make it easy. 10. Jeez.
okay.
It's 5 miles away, guys.
So we're gonna call that 43 miles just for kicks, right? It might be a tenth off or two.
Bless you.
Rifle,
17.
Yeah, that's it.
is that right?
Yeah.
Okay. Okay. So don't ever accuse me of not giving you an easy problem. How far is it from Rifle to Glenwood?
20.
26.
Thank you, Alec.
Back.
This is why you
What?
don't get easy problems.
Gracious.
Okay.
How do we add it?
I told you 100 times, keep the problem simple. Okay, so if we travel, if somebody travels from Parachute to Glenwood Springs and back to Rifle,
26.
okay? The displacement,
17 miles.
let me put that in a different color.
Thank you.
Let's use that one. The displacement is simply this distance, correct?
Yep.
Okay. Go away.
Okay, we'll leave.
I wasn't talking to you guys. Thank you. Okay, now, mathematically, if you have a function or a graph, you're probably gonna need to do the math like we did. Right? Okay, how about distance traveled?
Please God, tell me this is on the AP
The concept
So
is,
easy.
If you go
The
from
concept is-
Parachute to Dagger back to Parachute.
I'll show you an example problem. Okay, distance traveled,
Since I fly.
43 plus 26. Okay. Okay, what is the difference between these two?
Addition versus subtraction.
Okay. If could I write this as such? Okay. Could I write distance traveled like this?
Yeah, you can.
Is that right?
It's more right, but yeah.
That makes sense. That's how we deal with this in function format, is with absolute values. Okay, so when we have a function of some sort, the displacement is simply the integral of the rate or velocity function from some time to some time, right? Time 1 to time 2, so we have our integral limits and our derivative of the velocity, and we evaluate. Okay. So that's straight up something you've already done, right? Distance traveled simply as this. So any negatives, as is this, turn to positives. So we're now adding all of our distances up.
Oh, that's it.
Now, so we just have to deal with the negatives if they come up, whether graphical or in a function. Okay? Basically, what this amounts to is you have to figure out where the function's negative, and you split it into two different integrals. Okay? And I'm going to show you one. So you would find zeros, you would figure out where a function's negative, all that stuff, using what we learned. Okay? Okay. One of the famous types of problems that we have are called particle motion problems.
What about this?
So this is basically where a time gives you a position or a velocity, and you do some work around that information. So here's an example. So a particle has velocity. There's a function that defines the velocity based on time. Calculate the displacement of the particle from t equals 0 to t equals 6. If you want. You can do it on your own if you think you can. Okay. Okay. Always be aware of where you're starting. Right, velocity function. Where you're asked to go. That is a position change.
You're going from velocity to position.
How do we get there? Yeah, integral. So be careful that you are given a velocity function first. Don't just pull the trigger on that integral. Okay. But as we discussed before, we are going to use the displacement.
Is it absolute value?
Displacement is not absolute value. You have to, again, make sure to keep that straight. So, what are our times? So it's 6, and our velocity function this would be a non-calculator question, guarantee it. So if you're on your homework, I know it's very tempting to make it easy. You need to practice these by hand.
What?
If your input right.
Yeah, so your integral good. Add 1, divide.
And then 12 to
big problem. Again, make sure your notation is good. Just a side note, I did see a lot of this on the quiz. You don't need that. Okay. You don't have to put that. You can put equal sign here if you want.
I usually, is this on it? 'Cause I usually just carry it down from the top one and just put equal to and sign.
Oh, like this way?
Yeah.
Yeah, you're good. No problem. This is just my natural state mode of operation here. All right, now evaluate, right?
That is,
Are you making fun of me?
Yes,
that's
they
your
are.
natural state.
So they said this is your true form.
Okay, I'm lost. We'll mess with you right now.
That was just the same thing.
Do I need to worry about the zero? No,
No.
thankfully. We plug zero in and we get nothing. Okay,
So what's that last one? The 24/6 squared or 2? Can you turn that into just a 12?
12, yeah. All right, so we are at the point where we can have an acceptable free response answer, right? Or sort of stop
That's an acceptable answer?
in a free response. Now, multiple choice is going to carry this through, right? So that's why we practice it. Really? How do you know that?
He put it in his calculator.
No problem.
I don't care. You should just.
36.
Yep.
Meters per second.
No credit,
Meters
because
per
there's no
second.
units. Nope.
You didn't specify.
Meters per
Oh.
second squared?
Velocity is meters per second.
Yeah, position. is
Position change,
It's meters.
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 Okay? You can't travel to Glenwood and say, I went 36 meters per second.
I mean.
You say, "I went 36
Yeah, that's your
meters."
speed.
Oh, okay. You threw back at me when I was saying, you can, it's not correct.
What was that for?
Brandon, you're like a cat that needs to knock everything over.
Good. Okay, so displacement's just a straightforward integral, right?
Okay.
Have fun hearing that on the video.
What about,
Oh,
I'm shoulder checking you.
ouch. I'll do video. Sorry. This is my natural state. I will fight.
distance traveled?
This is my natural.
Oh, great.
How are you gonna
Same question.
Okay, it's, 1,476.
Yeah, you copy that from the book.
I have the numbers right here.
You bum.
Okay, so how do we deal with absolute value in these problems? That's the question.
You just calculate.
No, you have to. The question you have to first answer is where is the function negative?
Everywhere and nowhere.
At the state,
Okay, I'm pretty sure that's not possible.
And you just
Draw a triangle. Oh, man.
Okay,
nice question.
that's the question. How do we figure that out algebraically?
I don't know.
table of values.
Yep. Okay, so
Oh, wow.
same, like, do you notice the theme this year? Pretty common, right?
Yeah.
Set the function equal to 0, and then we'll do a sign analysis. Okay? Sign to sign have two eyes in it,
Sure.
No.
No, not at all.
just today, right?
I guess.
Because the world says that I can define my reality.
Yeah.
Okay, what's the thing?
Essentially, it's so fine, because I'm using X.
Two words.
Ladies are not impressed by that kind of thing.
Not at all.
I wouldn't hope so.
Okay, if you're gonna solve this,
And solve it.
I never won.
what can you do?
Oh, you got everything?
Okay, so we're gonna factor. Okay,
Now,
is that factorable?
Oh,
That's the first question every time, right?
yeah, it is.
6 and 4.
Why'd you put A?
Not quite 6 and 4.
Negative six.
Negative 6 and negative 4 works. Okay, what are my t-values then?
4, 6.
And
Answer.
And 0.
0, 4, and 6.
Oh, yeah.
Right, so 0. Okay, so you solve the equation.
Yep.
Now we do a sign analysis. So V at what value?
2.
Okay, I'll pick 1 because it's probably easier. 1 minus 10 plus 24 is positive, right?
Yep.
And then, okay, let's do 5. 5 cubed, 125, minus 250,
It's gonna be positive.
you sure?
Negative plus a positive is not a positive.
Uniform and stuff.
Isn't it?
Here's the easy one to use. Use the factored form. 5 is positive, 5 minus 4 is positive, 5 minus 6 is,
Negative.
we get a,
Negative.
okay. So algebraically, you just figured out where that function is negative. Okay, so that's your best option for exact, but if you have a calculator, I graph that beast. You're gonna see this
Voila.
right there.
Whoa!
Positive, negative. And you can just do a 0 calculation with your math, right? Calculate your mind. Okay, so what do I do with that information?
That's your velocity, guys.
It's the velocity function.
Can you not have a negative? I thought you couldn't have negative velocity.
You can't.
Velocity negative, what does negative velocity mean? Traveling left. It's just a direction indicator, right?
So it's going positive from 0
So this
to 1.
particle is traveling right,
Right.
traveling to the right, and then it gets here,
There, it goes
turns
to
the
the
corner and travels left, just like the Glenwood Springs are in that example, right? We have to split our integral up. 0 to 4,
And 4 to 6.
is normal. That's just positive, right?
Yeah.
Plus, right? Absolute value of 4 to 6.
Right. So there are a couple ways to handle that. One is to do this. It's the absolute value to answer. It's an option because you'll get a negative if you absolute value that, right? Here's the other option. This is what I use. This pumps out a negative. Negative times a negative is a positive. So either of these work. It's fine. All right. If you want to practice this on a calculator, you can go get one. That's where I want to do it. This is doable by hand, but in the interest of time, you're probably going to see this as a calculator problem. Okay.
Luis, you need something?
Are they even friends? Sundays.
Who kills that? Yeah, that's embarrassing. It's totally on the internet. Well, I can't double click. Fantastic.
Turn it off.
What's on the
Yeah, you go through
Yeah, I know. They're on their phones on Sunday.
Where what?
Where do you put the function? Right equals, okay, there you go. Use X.
X is the key.
Yep, it doesn't matter what variable you use. Your calculator doesn't really care. Hey, there's your function, right?
Graph.
Don't need to graph it. We've already figured that
But I
out.
want to.
Okay, so
Work.
go to the home menu. How do I put those integrals in?
You do,
Alpha calc.
No.
Dang
I was in a second.
Math,
Dang it, I was close.
9.
9. Okay, 0 to 4.
Second.
Where do I grab my function?
Alpha trace.
Okay, alpha trace, y1
Minus.
minus.
Come on.
49.3333333.
Okay.
What is my
Then you press enter. And you get an answer. 49.333.
But actually, we take 3 to 1.
How about we just use 1/3?
No, doesn't work. That's the easy way out. You gotta be a man right out every 4 3.
Why does mine keep
Brennan, I would love to see you try.
I would
Never
never.
hand, so it'd be.
You would use all the paper.
So, questions on
Never change.
calculator versus no calculator?
No.
Or what we're working
I
on?
found a 2 on one.
Hey, we're almost done. Hold yourselves together. So the hard part of these is recognizing what to do. Okay, you've done this math now for a couple of weeks, but you have to read the problem, analyze it, figure out what to do. Okay, that's the point that we're at with a lot of this stuff, because we've done most of the basic calculation type stuff, so. Any questions? Okay. So let's,
Hey, Benson, anything here, anything, a picture of you.
Oh, yeah, he is. Oh, man.
84 ERA.
You need to put that on the drive monitor, just to read up there.
We were planning on putting it in the computer lab, putting it in the screen.
Do it. I'll do it on my
okay, so, this,
You probably have.
no,
Next Tuesday.
how about, let's say this is due May 8th.
Okay? Okay.
I'm just kidding.
No, you're right. No take backsies.
Um,
No take backsies.
That's on the
Just so you
video.
know, that's for.
I'll take it back.
forever on YouTube?
I'll do it on
I'm living by it. Pause the video right before you scribble it out. Be like, you moved it like that.
Too bad. I
You didn't consider the entire context of the situation, and you failed because of that. No. Today's the 5th, correct?
Yes.
Okay, so this would be due the 7th,
Okay.
since I'm being clear. May 8th. Tomorrow, we're gonna work on a graphical representation of this. Shall be class activity. And, these spiraling problems are as important as the new stuff. I've taken a lot of the new stuff. There's only 5 problems there. And so put some effort into that free response. If you have questions, I can answer those tomorrow. Okay. All right.